related questions, I think the team is going to have a separate session for the students. Okay. So the particular orientation session will only delve into the course structure, the aims and objective of the course, and the week-wise content for the course. Okay. If you have any queries or questions, please put that into the chat section while we are presenting. Once the presentation is done, we will open the floor for the questions, and you guys can ask us questions at that point of time. If that is clear, I think we can get started with the presentation. So should we start with the presentation or should we wait for a few more
Yes.
minutes?
Yeah, I think, we have waited 5 minutes, 4 minutes, so let's get started. Yeah.
Okay. Uh, Hello, everyone. Good evening. My name is Sushil, and I am the course instructor for this particular course, Introduction to Linux Shell. Apart from me, Santana Krishnan will be another instructor for this course. Of course, the course faculty here is Professor Gandham Fanikumar, sir, as you can see his video. Um, so this course is foundational level course. So the general structure of this course would be, there are 5 credits given towards this course, and of which 3 credit will be towards the theory, and 2 credits will be towards the lab. Okay. More on that I'll discuss it as we go along. Okay. So the programming in C is the core requisite for this course. There will be the exams which will be conducted for this course will be quiz 1. Then you will have 2 OPPs, OPP 1, which will be at the end of week 4, and then OPP 2, which will be at the end of week 8. You have an end term exam. Apart from that, you will have a non-proctored programming exam, 2 of them, which will be scheduled a week before the OPP1 and OPP2 respectively. And then you have graded programming assignments as well as quizzes each week. Okay. So the total, the quiz 1, GRPAs, NPPs, and end term will constitute your 60% of your course grade, while the OPP1, OPP2, VM tasks, and bi-weekly lab, which will constitute 40% of the weightage. A detailed description of how the breakup would be is given in the grading policy document. Okay. For the end term eligibility, it is compulsory to attend one of the OPP and should have more than 40 marks in it. And the average GRPA score should be, give me a second. Yeah, so the average GRPA score should be also greater than or equal to about 40. So we'll make use of best 5 out of 9 GRPAs, which are spread out across your weeks. The course grade eligibility, you need to attend the end term exam, and you need to have at least one of the OPPs score should be greater than 40, and you need to attend all the lab activities and complete the activities plan in each of the lab session. Okay. So as to show you the general timeline of the course, on 19th we will start our term. The first lab will be around 3rd of February. The lab timing will be updated to you via email, but for now the timing is from 10 a.m. to 1 p.m. Okay. So the first lab, there will be 2 labs in the February, one on 3rd and another one on 17th of Feb. And you will have your first quiz around 25th of February. Okay. The content, like first 4 weeks content, will be the component towards the quiz 1. Okay. Then in the month of March, you have again alternate labs, right? So you have on 2nd of March, 16th of March, and then 30th of March, you will have consequently 3 another labs. So total 5 labs will be there. And your OPP is scheduled on 10th of March, your OPP 1. Again, the syllabus will be for the first 4 week will be the syllabus for the OPP 1. And NPP will be scheduled in the week from 3rd to 9th. Within this duration, we'll hold up non-proctored programming exam. The OPP as well as NPP will be conducted on virtual machine, which will the details of which will be shared during your first lab session. and we will help you configure all of that, and we'll get started with that in our first lab. So apart from that, all the labs will also be conducted in the virtual machine environment. Okay. The second OPP you will have on the 7th of April, which will have first 8 weeks of content to test you. So, and then you will have an end term on 28th of the April. Okay. So, yeah, I think Professor can take over for this
Yeah.
particular slide. Yeah.
So, friends, thank you, Sushil. So, friends, the one of the purposes of having this session is for you to see and learn about the need for this course. As you know, all the core courses are designed keeping in mind what are the expected capabilities from the student doing the electronic systems course. At the end of 4 years, the kind of things that you will be involved in the industry job, and what are the skills and knowledge that people are expecting. So that is what is kept in mind. So with that reason, the Linux course has been made as a core course. Now there are 5 points that I want to bring to you. We will have some videos to strengthen these points shortly. One of them is already recorded, and we will be sharing it to you after we edit it. And for the remaining ones, we will have provide some case studies. So let me just go over these 5 points, though it may take a couple of minutes. So the first thing about the reason why you should learn Linux shell is because you need to have automation in most of the embedded systems. As you know, embedded systems do not entertain a human interaction. They must be autonomous, and therefore you must have ability to have scripts which will not wait for any human interaction and then go on to execute as per the logical system that has been programmed. And Linux allows you to imagine such an automated script and to let you also try some of it during the course. Okay. Then second thing is stream input processing. By that, what we mean is when you have a circuitry which is receiving analog or digital input from somewhere, and it has to process it and then send the output to elsewhere. Usually this happens when you have a neural processor, or you have a video analytics equipment, you have got, let us say, a machine vision equipment, and so on. So in all of them, the input is continuously coming in as a stream and it has to be processed. So again, in such situations, a shell program helps you in diverting the parts of the input stream to be processed by various programs, various executable programs, one after other, and then sending the output to a particular, program that will display or, show some output in the end basically. And that is an example for which we have a video done thanks to Professor Janak Raman from electrical department, and we will share that video shortly as part of this course. Then third thing that we must realize is today we are in the era of cloud computing. So when we say we are actually going to work on a Linux computer, it is not likely that you are having it in front of you. Usually, we have to solve problems and offer services for people who are remotely located. So all our programs will be actually running on the cloud. Cloud, in the sense, it is a remotely located computer, and for you to access it, the very first thing that will be available is a Linux shell. Once you have the access to the Linux shell, then you can launch some programs such as remote desktop, and then you can actually look at the desktop screen, and then you can go around working with it. But if you do not know how to work with a Linux shell, you cannot even actually have access to the cloud instance. And therefore, it's very important for the new generation of students to be able to work with Linux shell if they want to take advantage of the cloud computing paradigm that we are currently in. The fourth aspect is about remote diagnosis. By that, what I mean is that you have many equipment that may require certain diagnosis. You want to connect to that equipment probe some of the inputs, check what is going wrong. Maybe certain circuitry is wrongly wired or wrongly, flashed with the system settings, etc. So some of these settings require you to perform very low level diagnosis. By low level, I mean as a machine level, commands. And such commands can be passed on to a particular device at a particular address connected to your computer or the chip very nicely using Linux shell, because the Linux system allows you to talk to any hardware device that is connected to the computer, and you have ability to have a Linux kernel flashed on to most of the electronic devices, and therefore the shells can start talking to the devices that are connected. So remote diagnosis becomes very much doable the moment you are able to work with a Linux shell. The last thing is about the speedy execution. That means if you have a humongous amount of data, millions of rows of data that has to be processed in just a fraction of a second, then you cannot have them displayed as numbers in front of you, rendered in front of you as data that is in human readable form, and then allowing you to go ahead and write some scripts or click on some of the buttons, etc. That is very, very, very slow. So for many of the operations, the execution is very critical. Sometimes it becomes the reason why a particular circuitry is going to be acceptable or not. Particularly, for example, in computer vision, if the decision is not taken before an object is, pushed out of the conveyor belt, then there's no point in having such a circuitry. So speedy execution is often given by a constraint externally, and that can be made possible using the Linux shell, and it becomes very, very powerful the moment you are able to do that. Okay, so these are the reasons that I can readily come up by talking to the electrical engineering faculty on why Linux shell is a skill that they expect from every student who passes out of their department programs. Yeah. Sushil, we can go to the next slide.
Yeah.
Okay, so from the course, having discussed with the faculty and looking at the objectives, so we have written down what the course can offer. Considering that you are in the beginning stages of the program, we have thought of the following things. We will introduce the Linux operating system. You may want to know that the mobile operating system that you have, Android or iOS, are basically variants of Linux only. The kernel that runs inside is essentially the same heart that is running, and practically every supercomputer in the world is also running the same Linux, and all Apple computers are also running an operating system which is similar to Linux. It's called basically a variant of Unix, and so you have to see that even Windows, Microsoft Windows, has actually a Linux subsystem. It's called the Windows Subsystem for Linux, WSL. Okay, it is available as a part of Windows today. So practically every computing device that you have today in the world is having an ability to run Linux OS, and therefore if you get to know about it, it's good because you can take advantage of it. And specifically the skill that we want you to be having is ability to work with the command line interface. So to be able to write some commands and then launch programs and seeing how they can be used to solve some of your problems is the skill that we want to you to have, and this will come only by practice. So I urge you, please spend enough time every week to practice with the command line. We are going to give you access to a virtual machine where you can try some of the commands. You will have a laptop. If it has Windows, you can install Windows subsystem for Linux and have the Linux command line, a shell available on the screen. And if you happen to have a Linux laptop, that's great. Nothing like it. So you have ability to have access to command line on your laptop, and please use that to practice. It's very important. Okay, without practice, it's not possible for you to do well in this course, and please don't neglect that. The third point is most used inbuilt commands we are going to tell you. That means, see, there are thousands of commands in Linux. Okay, it's not as if we want you to learn all of them. What we are going to do is pick a small subset, okay, couple of dozen such commands which are very useful, proven by many people across the world as the most important commands. Those are the ones which we want you to learn, and we are going to give you assignments which make you learn those very well. And one of the things that you need to also learn is to be able to create, edit, manage files and folders and their permissions, particularly the permissions, because that actually helps you in imagining automated systems later on. Naturally, you do not want your automated system to be hacked by any arbitrary computer that is connected with the network, and you want to protect the data and to be used only by the people who are supposed to use it. So this whole idea of access control is very nicely handled in Linux. So the earlier you get used to that concept, it's better. So the file permissions, folder permissions, etc., we'll be learning, and once you have a grip on it, then you will see that you are able to control some amount of the security aspects of the files and folders. Now, generally, these commands in Linux are not one per task. Usually, you can combine multiple commands together to achieve the solution of a particular task. So this way of combining the commands one after other, how the information will flow as output of one command is input of another command. So that kind of a flow of information across commands is going to be taught to you, and that will actually help you imagine how you can actually combine known commands that you already have to solve a problem. So we don't look at a monolith solution for a problem. We see how we can use known commands to solve the problem. Each command comes with several options. So how do I choose the right option and combine some 2 or 3 such commands and achieve the output that we want? So that is going to be the important aspect that we are going to convey across, and that you will also start gaining advantage the moment you start practicing. And the Linux operating system, we are going to use it with the Bash shell. And Bash is also a language. Okay, so like in many languages, it will have statements, it will have loops, variables, and environments, etc. So we are going to give you introduction about that. So you will learn Bash as a language also, and you can start writing scripts. So when I use the word script, do not get scared. It's not like you're going to write hundreds of lines of bash script to achieve the solution of a problem. No, even if you write one line, it is actually also eligible to be called as a script. Okay, so you basically write a command, keep it in a file, and then the file can be called as a script. That's all. Okay, and the moment you start learning that, okay, can you please go back to the, yeah, so there was some mistake. Okay, so when you start writing multiple commands and then put them in a file, that script can then be given proper permissions and can be then put on an embedded device, and then can be made to run automatically whenever the device is powered on, and then suddenly you see that your device is actually alive. Okay, that means the moment you power on, it is able to perform some actions. So when you are learning bash scripts, please remember you are eventually going to use them as scripts that will automatically run, perform tasks, and make your circuitry or an embedded system live. Okay, so it is a very fantastic path to achieving your electronic systems to perform the actions, and so take it seriously and start learning. Okay, and there are certain features that will help you to do tasks very fast, which are also available in multiple other languages, such as regular expressions. So this is a concept. Regular expressions is a concept by which you can actually look at pattern recognition in the input stream of data and work with them in programs and in commands. So I'm going to give you an introduction. We will not go in depth as we have done in the data sciences programming program, BSc program, but here in electronic systems program, we will tone it down because you're only first year students, but you will actually be introduced to the regular expressions, and you will see the power of that as you start using them in the scripts. Just to give you an example, there's a lot of text and some of those words look like a PAN number. How do I recognize that number alone and take it out? Okay, so such a task, for example, once you learn regular expressions and bash script, it becomes trivial. Okay, it becomes very easy for you to do. But for a human, it will become very tricky, because if you have a million lines, it is actually not possible humanly. Okay, whereas a computer program can do it in less than a second automatically. So you will learn all these skills as a part of this course. Okay, so let us go to the next slide. Okay, so the approach for this course is very different from many other theory courses. So please remember, this course is actually 3 is to 2. There are 3 credits for the theory component and 2 credits for the practical or lab component. But this course itself is heavily requiring you to have a practical approach. That is, the videos are such that I expect you to watch the videos, pause them every few minutes whenever I run a command, and you run the same command yourself, see the output, compare with what I have got in my video, and then go forward. So if you do not practice while watching the lecture video, then it will become difficult for you to try on your own later on. So it's very important for you to have a Linux shell open, kept open beside the YouTube video. And as you watch the video, keep pausing it and keep trying out the commands. So that hands-on approach is very important. And we are also going to insist that through the lab component of this course. So hands-on approach is what makes this course very different. And from the very beginning, you must have practice. Okay, and we also do give you additional support. Okay, and that we will do by various sessions. So instructor sessions will be there. The 2 instructors for you, both Sushil and Santana Krishnan, will be holding the sessions for you, as in the, as already told to you in the calendar. And I will also make myself available for many of those sessions, and we can actually give you help where you can overcome some of the doubts you may have, and then you will start exploring the command line in depth. Okay, so hands on is the key. Okay, it's not just the theory part. Okay, and what we expect you to do is you should practice. Okay, it's very, very important. You have to practice. And whenever we have the lab session on the virtual machine, we want you to participate in that, because that is the future. That is a job that you will be doing. Okay, that is how things work in the industry. So you must actually log into the virtual machine, follow the instructions, perform all those actions. We will be noticing how often you are logging in and how long you are spending time, etc. And that is all going to count towards your attendance as well as grade for the lab component. And so do take that seriously. Without practice, it's very difficult for you to understand, because as you know, skill comes only by practice. So every week I want you to practice, and every 2 weeks when we have the lab session, please participate in that, because it will help you to get a good grade eventually from this course also. Okay, yeah, so next. Yeah, so next few slides, again, Sushil will come over, but I will be there. I will be there, happy to answer some of the queries towards the end of the slides, and we can also have some discussion as necessary. So the agenda would be basically, we will be introducing the Linux or Unix kind of a thing, operating system for you, and we will also give you the structure of the course and weekly concepts we are going to show you. Okay, so next.
Yes.
Yeah.
Like Professor has said, let's look at the what Linux is or what Unix is. So Linux is something which came after the Unix operating system, which was developed by Ken Thompson and Dennis Ritchie at Bell Labs. What it allowed people to have multiple users for a system, and allow the hardware to be managed by the kernel in such a way that the resources are used optimally across the users. So basically, what shell scripting or where the shell scripting comes in, if you look at a typical layer, you have a hardware layer on which kernel is there, and the shell programming, the shell script actually talks to the kernel, and the kernel, gives you the resources, right? The hardware resources for that particular program. So this is especially important, like Professor has said. The Linux kernel, as such, is being used in numerous devices across the industries, and it is one of the key components, especially when it comes to IoT. So understanding how the shell program interacts with the kernel and how to automate, set of commands is something you will learn in this particular course. Okay, there are also certain programs which can be automated by using shell scripts. Say for certain programs, like for image processing, you have certain set of programs which will allow you to have a command line interface. So by using that command line interface, you can process thousands of images just by using a simple shell script. That is something which it will allow you to do at the end of this course. And like Professor has pointed out, we expect you by the end of the course, you should be able to create a script, run a script, do the permissions modification, understand how to generate a workflow given a certain task. Okay. So basic file structure, right, is little bit different than if you had used Windows before. In Windows, you have a C drive, or you may have also additional D drive, E drive. But the idea is that all of the system file resides in your C drive alone, right? And then everything else is what you can use as your space to store files and do certain operations, right? In case of Linux, the file hierarchy is very important, and that you will learn in the first week itself, right? Each of this folder, like, so the forward slash is just your root folder, and each of the folder which comes under this root folder has specific purpose built in. And all of this is very important, especially if you're going to create shell scripts for your say VLSI systems or embedded systems, right? And how they can be used to do certain operation is something you will learn eventually as you go along the course, the full BS course itself. Okay, so this is a general file structure hierarchy, and we will talk about it more in detail in the first week in itself. Okay. So moving forward, I just want to give you a primary structure of the course. As of now, we have 11 weeks of content. And as you can see, the key aspects which we will look into this particular course is, how to handle file and how to manage it. Then there are a set of commands which we would like to introduce to you, and we expect you to know how to use them, how to manipulate different input and output just by using these commands. Then we would like to also, expect you to learn the process control and how to, look at all processes are running in the background or in the foreground, and how to control them, and what all operations you can do with that. Then the essential part of the scripting is where you need variables, and how you can use shell variables along with all of these commands to build shell scripts is what we will look at it. Another part is, which is very important, like Professor has pointed out, is regular expression. You may not do a data processing like in a data science course, but you will be doing a lot of pattern matching when you're building your make files, right? To or you will use a lot of shell variable or the concepts therein to build your make files and other stuff in the course. Apart from that, we will also introduce you to the grep, make, sed, awk, and git. These are the very essential tools which um as a practitioner in the course you will be using more often. Okay. So the week by week content divide is, in the first week itself, we will introduce you to most of the commands which will help you, uh, do file management, the certain ways by which you can use brace expansion, how to look at, file its statistics, the size, all of these these commands will be covered in the week one. Week two, we will introduce you to the command line editors, and we would like you to know how to write, how to open a file, write in a file, and how to edit a file using these editors. In week three, we will be teaching you how to combine files or commands in Linux, how to do process control, how redirection works in the Linux operating system, and how we can do some software management using dpkg and apt packages. Okay. Then in the week four is totally dedicated to the pattern matching, where you will learn POSIX standards for BRE and ERE, and then you will look at grep, egrep, and then related content regarding the pattern matching. In week five, we will introduce you to the shell variables, and in the subsequent week six and seven, we will introduce you to the bash script. So combining all of the things which you have learned from week one through four will be combined in this following 3 weeks, and you should be able to build bash script by the end of week eight, right? In week eight, we are introducing a special utility called SED, and a little bit about script automation. And we will then look at some of the awk programming basics of awk programming, how you can use it to manipulate data. Say you have logs generated, or you have a data stream coming in, how you can use Z and off to to edit it or to have a report generated from it. And then in week 10 and 11, you will have prompting, knowing your hardware, virtual control system, managing storage, concept of interrupts and sockets introduced in the week 11. So that is all we have for the orientation. If you have any questions, please feel free to ask now. I'll just open the chat section and I'll just take one by one all the questions. Okay. So the floor is open for the questions.
Yeah,
You guys
Sushil,
can ask.
so in the chat session, there were some questions and I started already answering them. So they can continue to use the chat and we'll answer them. But to just make it a little interactive, if some of them want to directly talk, I think we can welcome that for some time. Yeah.
Yes, sir. So what we can do is we can take some of the basic questions which they have asked, so that those people who are interacting through YouTube, they should be also
Oh, yes, yes, correct, correct. The
understand
chat, yeah,
what the
chat is not
questions were.
visible to them. Correct, correct.
Yes.
Yeah, yeah, yeah. Go
So,
ahead, go ahead.
so one of the questions Adish has asked is which software we will be using and how to install it. So Adish, like I have already pointed out, we will be providing you with a virtual machine which has Ubuntu on it. Apart from that, as a Windows user, you can use Terminal app, in which you can either install Ubuntu or you can install WSL instance in there and you can use it. For the Mac user, you already have Terminal inbuilt, so there shouldn't be any issue. And if you are a Linux user, definitely you will be just using the Terminal app. The point of this course is we will be just concentrating on the bash scripting. Okay. So the next question by Subhashish was which Linux distribution we will be using in this course. So, like Professor has already pointed out, we prefer Ubuntu LTS version like 22.04 or 20.04. Okay. Um, Sir, one of the question was, are there any reference books which we would like to recommend them? And a tip.
Yes, yes. So we do have some of the GNU documentation files that are open and free. So we will actually give those gnu.org website URLs for the PDF versions as part of the course resource, and that would be, I would say, most authentic information for those respective tools. Like for example, there's a Bash manual. Okay, there's a awk manual. Okay, there's a SED manual and so on. So those manuals will make it available, and you will see that the manual is actually quite elaborate. So you will again find that the slides that we are using and the videos will be more concise and more accessible information for you. But we'll definitely make those manuals also available to you through a set of links, and all of them are free. Okay.
Yes. So another question which Prasanna asked was how to write device driver and is it covered in the course? Uh,
Yeah, I have answered. We are not going to write device drivers, but it will be done in a higher semester because first year is too early to do that. But what do we mean by devices? Okay, how does a computer make devices accessible to programs? If you are wanting to, let us say, write some data to a particular device that is connected to your computer, how is it visible to me? That aspect is what is going to be shown in the Linux course. And then later on, when you write a device driver, you realize that you are basically making a device available to the operating system through which information can flow in to that particular device. So it needs you to go through these two steps of learning. And the first step is what is going to be covered in the Linux course. The /dev folder is where all the devices are going to be made available. And we are going to look at that as a part of this course. And that is your first experience of what does it mean by a device. Hmm. So let us go step by step.
yes. So one of the question Devanik has asked, what specification should I have in my laptop for a good experience and seamless flow of the Ubuntu uh, or a WSL?
Yeah, so
So
there I have answered, and I'll just tell you, if let us say you are going to launch Ubuntu as a virtual machine, then the laptop should have more resources. So if you are buying a new laptop, I prefer you to buy one which has 8 cores, like for example, i5 processor or Ryzen. AMD Ryzen 5 series processor would have 8 cores, and then the RAM you should go for 16 GB RAM. Okay, and if you have a hard disk of 1 TB, then I would say for several years you can use a laptop comfortably, and you can launch a virtual machine for Ubuntu, and Ubuntu virtual machine can be given allocated 4 GB RAM and 50 GB storage, and that would be fine for you to run the Ubuntu. Now let us say you want to actually launch Ubuntu as a native operating system, that is you want to have a dual booting or even a Ubuntu laptop. They are available from Dell and Acer and Lenovo. So if you want to buy a Ubuntu laptop, then you would not need too much of resource. 8 GB RAM is sufficient for you to see the Ubuntu running very well. I want to also use this occasion to tell you something. When you have an old laptop and it gets very hot because it is working very hard for you to show the Windows operating system, then you can actually have a easier operating with Ubuntu, because normally Ubuntu will take less resources than Microsoft Windows. Okay, so the thumb line is that your hardware will be working more efficiently.
yes. So I hope that answers the query. The next question Kaushik asked was why there is no in-person lab for Linux like there is for C programming. Hello.
Yeah,
Yeah.
yeah, yeah.
Yeah.
So I have also written that response. What I want to
Yes.
tell you is that for many of the other lab courses, the hardware that you need is made available to you in, or even the software is available to you in the lab. However, for Linux, you are working with the operating system itself, and you already have a laptop. Without a laptop, you are actually not accessing the videos. And even if you have a tablet, you have basically a computer. So anybody who has a computer already has the equipment with which they can do the lab practice basically, and that is the reason why the practical component of this course is starting during the course itself, and we are holding the lab sessions during the course, and your own laptop or your own tablet is the equipment for the lab. Okay, that is the reason why it is different from other courses. The equipment itself is for you, the one needed for the lab. Yeah.
So Krishan is asking how lab work will be done. So basically, you will have bi-weekly lab, and you will help you set it up the virtual your account into the virtual machine, and we will have you know um, a room set up for 10 students each, and there will be a tea assigned to each 10 of you. And I'll see we'll have set of questions ready for your lab work, and you have to do it while you are in the lab. Okay, so we'll keep track of all the activities you have finished in the lab and for how long you have been present in the lab. Okay, each of the TA will take note of that. So bi-weekly lab you need to attend. Is embedded C Ashmir is asking, is embedded C programming not in foundation course as mentioned in the academic structure? I think this is more of an operational related query. So I think the ops team will be able to answer that. Sir, Aditya is asking, sir, will all students have unique username in a
Yeah, I'm
single
just
VM?
I'm just replying to that. Let me just also just maybe enter that out. Okay,
Yes.
so we are not going to give one VM per user. That's not how it works. We are going to give a single VM in which all of you have separate usernames. Okay, you will have unique usernames, and you will be connecting. And sometimes when you connect, if you put a W command, you will see who else is connected. Okay, and you will see that so many people are able to work on a single virtual machine simultaneously, which is also one of the powerful aspects of Linux. It's a multi user, multi processor, kind of a operating system, and it works very smoothly when so many people are doing so many different things simultaneously. So you will be working in that mode. But tomorrow, after this course is over, and after you learn some more courses, later on when you are in the real life industry practice, then when you get a virtual machine for yourself, then most probably you are also the administrator for it, and then you need to know how to work with it, and you would have already learned it in this course. Okay, that is how it's going to be useful for you.
Sir, Venkat is asking, what's your advice for those who are very new to Linux or never used Linux till now?
Yes, so my advice is practice. Okay, practice, practice, practice. It's very, very important. One of the reasons we find students are afraid of Linux is because they don't practice. Okay, it's always basically about familiarity. You are familiar with the graphics user interface because for a long time you have been only using the mouse. You just click, 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 touch, touch, and that's how you've been working with a computer. Because you are used to that, you find that very convenient. That's all. But it's the same thing with commands. If you start using the commands, you find that again very convenient, and you can actually do much more powerful things that are impossible to be done with a human with clicking and on a graphical user interface. So you will see the speed, the ability, the automation, and all of that will be superior if you start using a command line environment. So start getting used to that with the practice. Okay, every week, couple of times you should sit in front of the shell, keep my video, look at what I'm showing in the video, do the same thing, repeat the same thing in the terminal, see how it is showing you the output, and that's how actually you can start gaining experience. So many students have benefited like that, and we have had very nice feedback from them that they have overcome the fear of the command line, and they're able to do some very serious projects because of the skill that they have attained through this kind of a course. And I encourage all of you also to do the same thing as you go. Yeah,
Yes.
Venkat
So,
Subhash has some hand raised. We just
yeah.
pause and see if he wants something.
Yeah, go ahead. You can ask your question if you're there, Venkat.
Sir, actually, good evening, sir. Actually, I thought to ask about the same thing. What if, I mean, what's your advice for us, for those who are new to this thing? Linux.
Sorry, I could not hear that very. There was some.
No, the question was, what is your advice to the new users of the Linux? So
Yeah, this
that's
just
what we just discussed.
just
Yeah.
know whatever discussing. Yeah, the
Yes.
same thing.
Sir, sir,
I want you to practice. I want you to practice by actually getting access to a shell on your laptop. If you are using a Windows laptop, then install WSL and you'll have a Ubuntu terminal. Okay, keep the terminal open and watch the videos and pause them every 2-3 minutes and repeat whatever I am doing in the video. And that's exactly how you can start practicing, and then that gets you the familiarity and you start learning the commands. So
yes.
that is the way. That is the way, best way to go ahead.
So the
So
best
just
way.
merely reading the theory about what is Linux and all that will not help. You have to type hands. That means I'm telling you, keep the mouse aside, keep using your fingers, type something, and then you start seeing the difference.
So it's better to practice along with your lectures.
Yes, simultaneously practice. That's the best way.
Yes. I'm asking this because we struggled a lot at this C programming, sir. As we people.
Hello, Venkat. I think we lost your voice. Can you repeat, please? Hello. Okay, I think there's some issue with the. Yeah. So Aditya, go ahead, ask your question. Meanwhile, I will wait for Venkat to get online again.
Am I audible, sir?
Yeah. My doubt was that this virtual machine, will it be hosted in the servers at IIT Madras, or are we going to use AWS or something like that?
Yeah, it will be in the cloud. Okay, it will be in the cloud. It will be, I think it is in Google Cloud. Okay, in fact,
Okay,
that
so
is that's
we're going to
exactly
be
the point.
using Google,
Today's world,
right?
when you have an IP address and you are connecting with an SSH, opening the terminal, And it really doesn't matter to us where is the terminal coming from Google Cloud or Microsoft Azure or AWS or Linode Cloud. It's all, for us it's all the same. We are able to work with it, partly also because the bandwidth is not such a serious thing, because commands don't take too much of bandwidth, so you are able to see the experience of working with a shell quite smoothly with most of the public cloud vendors. And even if it was a server which is located in IIT Madras, it would just be the same. Okay, we just chose to have it in the Google Cloud partly because the students are not from any particular geographical area in the country. They are from all over the country. So keeping it in the public cloud would mean fairly equal access to all of them. So that's a motivation. That's all. There's no other real reason why we have to go to any specific cloud.
Yeah. Sir, and just one another thing. What will be the specifications of the virtual machine that we'll be using, as in the RAM and the disk
You
space?
do not need to know. You do not need to know. We are going to augment the resources of the virtual machine as we see the need for it. Because as more and more students are simultaneously logging in, if we notice that there is a slowdown or some problem, then we'll augment the resources. But from your side, you do not need to worry because you basically log in and the terminal is available. You write some commands and see the output, and that's all about it. Okay, so therefore, it is not something that you need to worry about. Okay, we will take care of that.
Okay, sir. Thank you for clarifying, sir. That's all. Thank you so much.
Yeah, Venkata, go ahead. Any other student who have queries, please raise your hand. We will take your questions one by one.
Yes, sir, actually, what I thought to say was, I asked the same question because we suffered a lot with C programming. So, like, is there anything we could do in this 10 days or so? We are having 10 days for a course to begin, right?
Yes, yes. So what I advise you is if you have a Windows laptop, immediately install a WSL, that is Windows Subsystem for Linux. Okay, WSL is readily available from Microsoft Store. You just search for WSL, and from Microsoft Store there is a WSL install help is available, and you have to open the PowerShell and type one command which is available there, and then immediately WSL is installed. So you'll have Ubuntu shell on your laptop. The moment you have Ubuntu shell on your laptop, then you should be curious, what is it? What do I do with it? How do I write some commands and enter, and how do I come out of it, etc. So then once you start fiddling with it, playing with it, then you will start seeing that the content that I am teaching in the course videos start to make sense, because then you can start trying the same thing yourself. There's no difference from the terminal I used in the lectures and the terminal that you are getting from the WSL. Practically, they are all the same. Okay, so start like that. So get WSL on your Windows laptop today. That would be my advice.
Yes, sir. Thanks for advice.
And it's free, by the way. You have already paid for it. Okay, once you have a Windows laptop, you have already paid for it, so it's already with you basically.
Yes, sir. Thank you, sir.
Welcome.
Yeah, any other questions? Yeah, so if you guys don't have any other questions, I think we can close the session perhaps. Hello?
Yeah, so I just, Sushil, I just finished one last query. So Aditya Rao was asking something. Saying, as in accessing the virtual machine from a browser-based terminal. So there are two major ways of accessing a terminal. Even if you are having browser-based, it will still have to talk to some computer on the back end. And so we have some systems like Replit, where using your study.iitm.ac.in login, the Google domain login, you can actually access Replit browser-based terminal, and you can practice Linux there. It's absolutely possible. You are welcome to do it. However, we want you to SSH into the virtual machine that we have provided for you, because we are going to use that as a criterion for us to know how much of practice you have in the lab session, and it also helps you to be prepared for the public cloud experience in future. And because when you buy a computer in the cloud, what are you going to basically, find a way to access it? Basically, you have to SSH to it first. The very first thing is SSH to it. So you will learn how to do that in this course, and learning it as a part of the lab exercise is a very good way. So we encourage you to do that. Okay, so that is how I look at it. Once you have learned, later on you can always do the replit and such things, because it's more convenient, how it works, so that's fine, no problem. Okay, Debanik Kar is asking, does U type processor is good to what type? Maybe I think is asking what type of processor is good to go for WSL. See, WSL is actually a feature from the Windows operating system, and Windows operating system runs very well on both AMD kind of a processors as well as Intel kind of processors. In fact, even on other processors like ARM and so on. Okay, so you don't have to worry. You buy a laptop from your favorite OEM like Dell or HP or Acer or Lenovo, or as you like. Basically, go for about 16 GB RAM, and that would work very well for you to run WSL and the Ubuntu shell on it conveniently, and it will work for several years also, because 16 GB is a very good amount of RAM for many of the programs that you will need as a part of the study. So no specific processor is not necessary. Okay, Ryzen or
I think
i5,
what
i5, i7, all fine. In fact, my laptop used to be i3, and I could run it continuously for about 6 years, and so therefore I got the money back in terms of performance. But maybe you are young people, you may not have so much patience like me. So i5, I would say, is pretty good. i5 16 GB RAM, or Ryzen, AMD Ryzen 5 series with 16 GB RAM will be excellent. 50,000 rupees is all that will take for the best laptop that you will ever need for this course. You can get it even for 35,000, but 50,000 if you can spend, you'll get the best laptop that you need. You don't have to burn too much money. Don't worry.
Otherwise, they can just simply use the VM which we are providing to do the practice.
Yes,
because
yes.
there they don't have to worry about resources. All you
Correct,
need is a
correct.
working functional laptop.
Yeah. Any functional laptop is sufficient. You can just connect your VM and you are ready to go. And therefore, any laptop on which you have internet access is sufficient as far as our course is concerned. And if Suryam is writing, I am using a gaming 16 GB Asus Ryzen 7 laptop. Excellent. I know it's really good. It would have so much of computing power that everything runs so smooth. So if you are already having gaming laptops, good for you. You have good resources that are in your hand. You don't need them, of course.
Yes.
Yeah.
Like Professor has already pointed out, whichever may be the machine, as long as you are able to log in using SSH from a terminal to the VM, all of your computational need are being taken care of. So all you need to do is log in and practice into the VM.
So, and for those who have the gaming laptops, I want to just throw a question to you. Gaming laptops have a graphic processor which is capable of enormous of computing power. It has a GPU, and so how do you run a program in a GPU? It's a curiosity that I want you to think. Okay, if you learn Linux, you are on the right track to use the GPU for computation purpose to solve scientific problems, and also to put it to some good use for analytics and image analytics, or some kind of a data processing, etc. So think about it. Learning Linux will be a very good stepping stone to make more out of the GPU hardware that you already have in your laptop. Okay, good. So we have only comments coming in our chat box. We don't have any questions as of now. So how are we doing with respect to time, Sushil? I think we are done, right? More or less.
Yes.
Yeah.
Yes.
So another
It's
2 minutes,
been
I think we will close. So if there is anybody with a pressing question, you can ask either in the chat box or by raising your hand. Vikas raised a hand. You want to ask a question? Go ahead.
Good evening, sir.
Good evening.
Am I audible?
Sure. Yes.
Yes, sir. As you said that you will be giving the access of virtual machine, so we will be taught that I don't know what is virtual machine, because I've never used it.
Yeah.
So we will be taught
Yeah,
in the course about it?
yeah, you will be taught on how to launch a virtual machine. It is part of the one of the lectures. Okay, it is there. Now you
Okay.
don't have to do that because we are already launching it for you and keeping it ready. You don't have to do that. How to connect with the virtual machine? We will have a session for that. Okay, we will be showing you, and my instructors, both Sushil and Santana Krishnan, are going to give you detailed, video on how to do that, and we will also handhold you to get onto the virtual machine through the SSH key. It's very straightforward, just a couple of minutes. But because it is new to you, you may need to pay attention. We will help you with that. So do not worry. You will learn what is a virtual machine and how to launch it, but you don't have to do it. It will be launched for you and it will be kept ready for you. You will just need to connect to that and then start practicing the commands.
So
This is
we have
especially
to.
important given that all our your OPPs and NPPs will be conducted in VM. So getting familiarized with the VM early on is recommended. And of course, in week 1 and week 2, we will be especially focusing on student to getting them on board onto the VM. So you will receive timely emails also and the session updates also where you can come and set it up with us. Yeah, go ahead, Vikas.
Okay, no, sir. That's all.
That is all.
Thank you.
Okay,
Thank you.
okay. Okay, guys, thank you for all your questions. We, I think, have had a very interactive session, and I hope you are now getting mentally ready to get into the course. Some orientation has happened, I hope. And as I also mentioned to some of the students, get started with your WSL and start, playing with it. And again, while I am going to close now, one last advice from my side: practice. Okay, practice. Okay, all the best, and we look forward to interacting with you during this course. My instructors and I will be very happy to support you through this course, and I hope you'll make the best out of this, and it will be a very good resource for you to do well in many other courses later on. Okay, thank you guys, all the best.
Thank you, sir.